It is very important that you have a true and accurate record of all your drilling. And here we do the logging, and the logging is done by my four geologists here, Victor, Francisco, Iro, and Christina. And we'll now take you over to see how the logging is actually done.
The first thing that we are doing when we are describing or logging the core is to identify the main intercept levels of mineralization. See what is the relation of this disseminated sulfide with the host rock. We are logging all the main features that we see, like coarse grain, alteration, is silica alteration, what is the distribution of the sulfides along the core, what is the intersections, if it's related to the cracks or joints. This is the main things that we are looking when we are logging the core. One of the main things that we are doing before to cut the core is to take the photographs, because it's more easily to get this record database with all the pictures to the computer. And apart from that, we are taking technical parameters, especially the lithology, the alteration, the joints, because this is the start point from generate all the information that will produce all the mine in the future.
We're well located within 250 kilometers from the Oropesa site. What we have in my back, ALS Chemex, ISO certified. At this particular lab, we do all the prep samples. We do the cutting of the core, the logging, the certified logging, the preparation, pulverization, put it in the envelope and send it to Vancouver. We air freight all the samples, and ALS has a system. So we get the results in 8 to 10 days time. Then we can plan ahead so we can get our next target for drilling.
What we got here is the ORPC2, what is one of the best holes that we are intersected in the Oropesa. We are defining at least 4 ore types in Oropesa. The first is the oxides, second is the massive sulfide, the third is the semi-massive sulfide, and the fourth is the disseminated. This piece of core shows what is the mineralized area in the core in this hole, which is the more high tin values are related to this oxide area. Here we got the massive sulfide that has been intersecting before during the ICME time. The massive sulfide that contain high-grade tin. All this area contain tin that has been remobilized from the granites that are below. This is the third ore type that we are getting. This is particularly interesting because we can see the fracture from where the tin has been running through the granites. And we can see how the first part has been remobilized through these fractures and had contained the high tin values. In this piece of core, we can see how the conglomerate doesn't contain tin, but we are pretty close to one of these structures. In a few meters, we can find this stuff. This is the disseminated, and we can appreciate in some cases what is the original bending in the rocks, that now has been replacement by the sulfide and with the tin. Here in this piece of core is easily to see how the bending is pretty well defined and is probably related to one of these big structures that has been carrying the tin. In this piece of core, we can appreciate very easily how the original bending is still on the rock and how the tin has been running through there related to one of these big structures. In that case, this yellow color is related to the clay and to the carbonates, and this more dark and metallic is related to the sulfide and the tin.